Hi, and welcome to Facial Recognition with Deep Learning, which is video 5.4. So let's get started with this video. So what exactly is facial recognition or face recognition? It's pretty much a buzzword right now with a lot of cell phones advertising facial recognition. You know about Apple's Face ID, all that stuff. But what exactly is it? Well, facial recognition is the ability to distinguish and recognize between individual faces. That way, you can provide a measure of security by using things like facial unlock. It's only supposed to recognize your face, just like a fingerprint ID. Our faces are particularly unique, and they're actually a pretty good form of security measures and almost as unique as your DNA imprint, unless you're a twin, okay? Twins actually have the same DNA as well. That's why they have the same face. So what makes this special, though, is that our brains are remarkably good at this task. But what is hard for computer vision is that it's actually a pretty difficult problem because there are very subtle differences between faces. What I'm going to highlight in this image here is the difference between good and bad facial recognition. Obviously, I'm not George Bush. This is me here. And this is good facial recognition. You want something to identify, localize the face, and tell you who it is. All right, so that's pretty cool. And that's what we're going to do in the next few videos. So why is facial recognition hard? Well, firstly, convolutional neural networks learn medium and high-level features quite well. However, these features don't really pick up the subtle differences between faces, which are things like just like a different size eye or different size nose or different cheekbones. We could look at these different faces here. So you need to have a way to extract these points and use it to train your CNN. So previously, a lot of shallow methods were used, shallow meaning that they looked at low-level type features. They were built using handcrafted local image descriptors. These are things like SIFT or local binary patterns or histogram of gradients. These are all basically just descriptor or feature descriptor methods. Now, I know we didn't teach this in this course. However, what feature descriptors are is a way of looking at interesting points in an image and only looking at the surrounding areas or regions around these points. You're going to take things like colors or histograms of gradients at those points, and you're going to use those to extract features from the image. So extracting features from only the interesting points and use that to train other classifiers or detectors otherwise. So problem with these things is that they never really had good performance in the real world. They were adequate in terms of figuring out who you were, but if there was someone who was closely or similar to you, a lot of times it would fail. And to be fair, even training a regular convolutional neural network, even if it's a deep network like one of the complicated ones like ResNet 50 or VGG 19, just throwing them a lot of faces, giving it to them to train, does not work well in practice, and you'll see why in the next slide. So traditionally, CNNs are very bad at facial recognition out-of-the-box CNNs, and here's the reason why. So let's look at actor Joey Tribbiani right here, played by Matt LeBlanc. That's his real name. Now, these are the images here. Now, all of these images are him. However, he's facing different directions here. His head is tilted back to the left a bit. Now he's looking down even more here. Again, this is the same image pretty much. And now his head is basically tilted the same way, but now he has a big smile and all of that is going on. So what's going to happen is that if you train a CNN, it's going to start looking at low level or all the features and learning a bit of irrelevant features, such as it may think anytime they get some training data with someone whose head is facing this direction, it might be Joey Tribbiani or Matt LeBlanc. So that's not good. You don't want your CNN to look at these sort of irrelevant features when training a facial recognition algorithm. You want it to look at everything, low level, high level, medium level. So when I said CNNs end up learning low level features or irrelevant features, I meant they could learn things like someone's a type of hairstyle or something can be someone else. I mean, yeah, those things are good, but in the real world, a lot of times these things fail. So now let's introduce one of the best attempts at this, which is VGG Face, which was developed by Oxford University researchers, and it was trained in over 2.6 million images with over 2,600 different identities. And you can look at these links here to take a look at the actual research and datasets here. Now, recently, last day, I believe, 2019, there was VGG Face 2 released. However, I've messed with it in Python a bit. It's not easy to use in Python as this one, although there's a very cool package from Keras that can work. However, we're just going to take a look at this implementation, which is quite good for our tutorial. Now, let's talk a bit about VGG Face and introduce the term Siamese networks. So now we spoke about the issue is that regular CNNs face when trying to do facial recognition. So how did these Oxford researchers overcome this? Well, they used and developed something called Siamese networks, which a way to use CNNs to extract pairs of features from different images and compare them. So you use something called Euclidean distance to compare them, but you don't only need to use this, you can use cosine similarity as well. So how do these networks actually work? Now, this is just a very basic diagram here that explains it. You give it a reference image, which is myself here. Give it a test image, which is President or ex-President Obama or former president. I'm not entirely sure what the terminology is. You feed these images into a Siamese neural network and it outputs similarity score distance metric. That's all it is here. And this Siamese neural network here, it's actually a convolutional neural network that computes these differences here. So what I would like for you guys to do, if you're very interested in how this works, take a look at the papers that are published, listed here on this Oxford University site. So how this works now is that instead of using hundreds of thousands of images of a person to train a classifier, which you would normally need to do, we can do something called one-shot learning here, which is super useful and super cool. Essentially, imagine that you have a new employee that joins your company. You just take one picture of that employee, load it into the database of employees you have, and you can actually just quickly create some sort of facial recognition tool that works quite well and will work on that single one image from that employee. You don't need to feed it hundreds or thousands of different images of that one person to train this convolutional neural network, or this neural network, I should say, to use for facial recognition. It works without it. So what have we learned in this video? We have learned what is facial recognition. We've learned why facial recognition is difficult for conventional convolutional neural networks. We've taken a look at VGG Face and how it works, and that delved us into how Siamese networks work. So now let's move on to the next video where we actually start implementing a VGG facial recognition similarity comparison in Python. So stay tuned.